Hi, in this video, we're going to solve a problem which appear in JEE ADVANCE 2020. So let's understand the problem. Here, we are given a limit or right-hand side limit. That limit extends to 0 plus, and it says that what is the required value. So basically, it's a problem of finding out the limit. Let's go ahead and try to find out the limit. So now, first we consider the given limit without any doubt and see that it is right limit. So therefore, we know that to finding out the right limit, we have to always use the relation that limit x tends to 0 plus fx is equal to limit h tends to 0, right? Fh, okay? Where h is greater than 0, right? This is the condition. So here we can easily convert in the h form where h is greater than 0. So therefore we can rewrite it at, right, limit h tends to 0, 1 minus h whole to the power 1 by h e to the power minus 1 and so on and so forth, right? That's it. Now see that if I substitute h equal to 0, it is obviously undefined, right? Because it will be 1 by each term is present. So therefore we need to go ahead with some specific logic, right? Let's try to apply that and see how we go ahead. So here, first we consider gh, okay, which is equal to 1 minus h whole to the power 1 by h, okay. Now here, to better understanding, we are using different function, right? But you can do the same problem, right? We'll see in the process, right? Without taking those function, right? We can try that, okay? There are no problem in that. So here we go ahead and take the function gh as 1 minus h whole to the power 1 by h. So therefore, the limit will be converted to h tends to 0, gh minus e to the power minus 1 and h by h. Now notice that any function gh can be written as e to the power of log of gh. So this is a properties of logarithm, right? So therefore, if I apply that property, it became limit h tends to 0 e to the power ln gh minus e to the power minus 1. Take that e to the power minus 1 common from that limit, right? So therefore, it will be e to the power minus 1 limit h tends to 0 e to the power ln gh plus 1 minus 1 divided by h by h. So now see that again, we get e to the power something minus 1 divided by something. Now, why we do that? Because we are trying to obtain or trying to rewrite that to get a similar form that limit x tends to 0, e to the power x minus 1 divided by x is equal to 1. Notice that we have e to the power of something minus 1 or divided by anything, right? So therefore, we can divide it by ln gh plus 1. Let's divide that. So now we can divide by ln gh plus 1, multiply by that, so the two lines will be equal. It's a very basic arithmetic. Now here we obtain two different limit, right? So therefore we need to calculate that. So first we take ph, another function we introduce, that is ln of gh. So therefore it will become l is equal to e to the power minus 1 limit h tends to 0 e to the power ph minus 1 divided by ph by h to the power a. So that's it. So therefore we consider it as also in that particular form. So therefore we can consider L is equal to e to the power minus 1 L1 into L2, where L1 L2 is given as obvious, right, to the separate limit. So now we need to calculate L1 and L2 separately, substitute it back, and our job is done. So let's go ahead and now calculate the L1 and L2 limit separately. First, we consider here that L1 limit, right? Now see that to obtain the L1 limit, right, we first see that L1 is equal to limit h tends to 0 e to the power ph minus 1 by ph. Now here, if h tends to 0 imply ph is also tends to 0, then only we can apply the standard limit, right? So that's why first we have to understand what is ph. So let's go ahead and take ph. Now, what is gh, right? ln gh plus 1. So it will be log of 1 minus h whole to the power 1 by h plus 1. Now, using the power law, it will be 1 by h comes outside. So it will be 1 by h, ln of 1 minus h and 1. Now, see that if I apply h tends to 0, it will be log of 1 divided by 0, right? It's undefined. So we cannot make a conclusion directly. So that's why we just expand that log 1 minus h by Taylor series. Let's go ahead. So therefore, we know that, right? Log 1 minus h in the Taylor series, or sometimes it's called Maclaurin series, right? Using that, right, we find log ln 1 minus h will be minus h plus minus h squared by 2 minus h cubed by 3 and so on and so forth up to infinite. If I divide it by h, right, we get it as minus 1 h by 2 and all that term, right? This is very basic. Now we need to calculate that one limit 1 minus h whole to the power h plus 1. Now see that every term in this expansion have h, and h is there in the numerator, right? So therefore, if I apply the limit h tends to 0, right, it will be obvious that pH is also tends to 0 only, right? Because otherwise, right, we h because 0 plus 0 plus 0 to infinity. So if I add infinite number of zeros, it will be 0 only. So that's it. Now let's make all the conclusions. It is obvious that h tends to 0, ph tends to 0. Okay, so therefore we can write L1 is equal to pH tends to 0 e to the power pH minus 1 divided by pH, which is the standard limit. So therefore this value is equal to 1. So L1 is obtained. Now our job is to obtain the L2. So now let's go ahead and find out the value of L2. What is that L2? It will be pH divided by h to the power. So now let's divide everything by h to the power a, and we get it as minus 1 by h to the power a and all the series, right? Let's keep it as it is. Now therefore, right, whatever the value, it will be L2 will be limit h tends to 0, 1 by ha, right? 1 by ha h to the power a, sorry, and whatever the series, right? That's it. Now from here, can we conclude anything? Yes, we can conclude something. What is that? Let's go ahead. So therefore, we can say that L2 will be L is equal to e to the power minus 1 into L2, right? Why? Because notice that here we obtain L1 equal to 1, L2 is already obtained in the limit, but still limit is not removed, and L1 e to the power minus 1 is present here. So therefore, we can understand the value of L, it's 0, non-zero, whatever, right? That depends on the limit L2. So now we have to analyze L2, right? Because see that we cannot find out each h tends to 0, the limit in L2. Why? Because a is unknown. Because depending on the value of h, right, the L2 values will vary. So let's go ahead. What we are asked for, we are asked to find out that for what values of a, right, the given limit will have non-zero values. So therefore our limit will be non-zero only if L2 is non-zero, right? So that's why we consider the limit L2, okay, and try to find out that for what values of a this L2 is non-zero. Now we just rewrite. Now notice that from every number we can take h common, right? So that's why it will be 1 by 2, h by 3 and all that stuff, right? That's it. So therefore, if I apply the limit, right, we can obtain, right, this is equal to, right, this will be equal to limit h tends to 0, 1 by 8. So we just separate this factor and we just separate the infinite series. Now the infinite series will convert to half, or maybe the particular limit is gives us half value, because if h tends to 0, everything else other than half will be deleted or removed. So therefore, we can say that L2 is equal to, right? L2 is equal to 1 by 2 limit h tends to 0, h to the power 1 minus a. That's it. So now, when it will be non-zero, it will be only non-zero if the limit h tends to 0, h to the power 1 minus a became non-zero. Then only L2 will be non-zero. So that we concluded. Let's go ahead. So now we see that L2 when non-zero. Now see that L2 will be non-zero only when different for different values of A. Now first we consider A less than 1. So the value of A is less than 1. What happened then? In then 1 minus A will be, let us consider it as B, and B is greater than 0, right? So it's a positive value, right? So if it is a positive, so therefore L2 becomes limit H tends to 0, H to the power B. So therefore, B is a positive number. So whatever happened, if B is a positive number, right? So let's go ahead and h to the power 3 or h to the power 3.5, whatever maybe. If I apply h tends to 0, it will give you 0. So therefore, L2 will be 0. Now, we consider the another case, A less greater than 1. Okay. So when A is greater than 1, so in that case, 1 minus A will be less than 0. So we consider it as a negative number. So here we consider it as minus B and B is greater than 0. Okay. So therefore, we find out L2 will be H to the power B. Now this limit, right, will become as limit H tends to 0, 1 by H by B. So if I apply 0, it will be in the form of 1 by 0 kind of. So obviously, it's infinite, right? Now, it tends to infinite, it existed or not, I'm not analyzing on that basis because in this particular case, that is meaningless. But yes, it is infinite. So therefore, we can say it will be minus infinity. Now, let's go ahead and take, right, that A equal to 1. Now, if A equal to 1, what will be the limit L2? It will be h to the power 0, and that's why it will be minus of. So therefore, we can understand that the given limit L will be attains its non-zero value when A is equal to 1. So that's why for this particular problem, we can say that that the correct answer is option D, which is 1. For L equal to A equal to 1, only the given limit will attain its non-zero value. Except any value, it is attains a zero value. And that's it. So it's a step-by-step explanation where we need the explanation of log x and all that stuff, log 1 plus x, Taylor series or Maclaurin series, whatever you call. So using that, we have to solve this particular problem, right? And now here, as A is unknown, so therefore applying the L-Hospital rule directly may not leads to a easy solution. Okay, that's it. Hope you understood the problem. Thank you.